All right. So in last class, I have completed up to that, security, which we have completed, how to protect the SOA composite application, how to protect the communication over the network in between the service provider and service consumer. So today, what we'll able to see, how to protect the server resources actually. After the request came to the server servers, how you're going to be protecting and what are the, security parameters we need to be do. That is, and how you're going to be protecting the server composite application. That is first one. And second one, how to set up the high availability environment. So these two we'll able to see. Then after that, if you have any time, so we'll see, performance tuning. Right. So why we are going to be securing the services and policies, because so whatever you are deploying, like BAM application or any applications generally, whenever you are deploying, that is like one service only. How you are going to be protecting those services, how you are going to be securing those services and policies, so for that reason, so we are going to be configuring this security. See, generally in the WebLogic server, so we will able to configure some parameters like that, without web services over there generally. But what we are here, all the components, whatever the developers they are going to be designing and developing, those are called web service components only. So that's the reason Oracle Web Services Security, which was introduced here. So for protecting those services generally, which we need to be go through that, or which we need to be configure Oracle Web Services policy or Oracle Web Services Manager, right? So what is that, and how you can able to manage with that framework. Then you can modify already some of the default security policies was there, how you can able to modify, then how you can able to create the new policies, then how you can able to attach the policies with web services, so while your design time and as well as at the time of deployment time, then how to monitor the performance with web services. All these generally objectives which you can able to do in the securing the services and policies. Let's we see the first one. So I told you the security, describing Oracle Web Services Security Manager framework. So that is what generally here, securing the web services, how you can able to securing the web services generally. So you can able to securing the web services by using this WebLogic server, web services, Oracle Web Services Security Manager generally. So there are following ways you can able to secure. One is transport layer, and the second one is messaging level, and the third one is SML2. So what is generally in these three ways generally you can secure the web service. Let's we see secure introduction to the WebLogic server security, what it is and how you can able to provide the security. See, whenever you want to secure your web service, generally what we need to do, so we need to be configure one or both types of securities, like one way SSL or two ways, uh, TSL security or message level security to protecting the web services or to secure the web services generally. Transport level security means, in other words, SSL only. SSL or TSL in the sense, TLS generally it is used to securing the communication in between the service consumer and provider. Just now, yesterday we have done actually, right? How you are going to be securing the communication between the service provider and consumer. Then message level security means it is going to be securing the messages throughout its journey, like example between the sender and as well as independent of the recipient actually, all those information it has going to be protecting at the message level. So in these two ways generally which we can able to protect the web services security or protect the web services generally. The first one we already seen actually, TSL, transport level security means, so it secure the communication in between the service provider and service consumer, right? uh, in the and the web services with security socket layer. SSL generally what it is going to be doing, it has going to be enables, it's a communication protocol generally which is used, widely used protocol. It is in the market widely used SSL generally. Then it has going to be enables the following features. The first one, authenticates the communication is established in between the service provider and service consumer in trusted way. In other words, it is going to be establishing the communication in between the two trusted properties. And confidentiality means, so whenever you are sending the data over the network, it has going to be encrypted. That whenever the data is exchanged over the network, it has going to be encrypted the data. And so message integrity, like example, the data is checked for the possible corruptions. So these are all the advantages generally which is provided by the SSL. So what is the disadvantage generally in this? So there is a one to point only secure the communication. It cannot secure the only one service like that. It cannot encrypt only the selected parties or the messages. It can do for everything. It can do for everything generally. Point to point only secures the connection. And in the sense, one after other, it has going to be securing the connection, and it cannot encrypt only the selected properties. Every party it has going to be encrypted before you are sending the information over the network in between the two trusted parties. So this we have done yesterday actually to protecting the communication. Message level security means, see, like web services generally how they are going to be sending and receiving the messages generally. So that message level security, which we need to be, what we need to do generally to protecting those soap messages in between the client application and as well as the web services. So digitally signed, the first one, and second one encrypted. Digitally signed means ensure the data integrity. Encrypted means ensure the confidentiality. So generally that the authentication generally which is possible by using the SAML tokens and securing the data, built in the XML message header. So in the sense, already it is there in the built-in XML headers. By using this end-to-end security, you can able to provide, and as well as it has going to allows parts of the messages to be signed or encrypted. And this is message level security. You can able to protect by using that, uh, SAM L2 token, and the sense for authenticating, and username generally requiring that X.509 or SAM L2 token. Anyone you can use, and assures the authentication verification. By using this XML message header, you can bring that, or you can assure data integrity, in the sense confidentiality. Let's we see what is a web services security overview generally. Example, when our clients make a request here, in the sense it needs to be know, right, the server, who are you generally. It will go to the web services security policy management. Here it has going to checks about that, and for authentication. So here needs to be provided that this request username token profile, like so in that, after that it has going to be signed in. Once it has going to sign in, it has going to be encrypt and propagate that information generally. Then after that, it has allowed to access the, if it is yes, it has going to be authenticated. After that encrypted, then it has going to be allowed to access the services. Else it won't access. In the sense, stops here only. It will send you know error to that service requester. Right. In this way, you can provide the data integrity, data confidentiality, and authentication. Authentication, which is possible by using the security tokens, and data confidentiality, which is possible XML encryption specification, and data integrity, which is possible XML signature specification. All these generally, which you can able to use in the web services security, you know, use these rules actually to protect the services. What is that web services security token generally? So it supports the following security tokens, like username and password credentials. Second one, Kerbos tickets, otherwise X.509 certificates. These are the two tokens, generally binary tokens for authentication generally. Secured asset, otherwise the third one, SAML, in the sense security assertion markup language, SAML assertion generally. So generally, in this way, generally you can specify in the XML format. So it has going to be authenticates. So what is SAML generally? SAML, in the sense, it's a open source framework generally. It's a open source framework. So for exchanging the security information in between the two different parties, or in between the two trusted parties, through the XML documents. So generally what it has going to be doing, it has going to be verified, so like, subject to the human users and as well as any other parties. By using the following concepts, it can able to protect or securing the web services, like authentication assertion, authorization assertion, and attribute assertion. So what is assertion generally? Assertion is nothing but what it has, we'll see next slide. What it will do? It will, based on the assertions, it has going to be, provide the security. And web services security with the SAML, independent, not independently, with web services security generally. See, SAML token generally, what it is going to be doing, which specifies how SAML assertions can be used for protecting the web services generally. Like example, web service security allows SAML assertion to be placed inside the SOAP header like this. And it has going to be, verifies it. Example C. So web services security provides a single sign-on or point-to-point security at the transport level or end-to-end security message level. See this one actually end-to-end security at message level at the message level. So and as well as authentication. So these two generally which we can call it as that question web services security which provides single sign-on which doesn't point-to-point generally which is possible by using the SSL. Right. So now you can understand the Oracle Web Services Security Manager, in the sense framework. So what it is generally, how it is going to be protecting. See, this is what Oracle Web Services, these web services generally what it is going to be. See, the developers also they can write, the policies and services depends on the requirement to protect their, services or components or composites, and at the time of designing also they can attach. Then after that, after deploying to that Oracle Fusion middleware control instance EM console, that time also you can able to attach the policies and role policies and services, application policies and application role, and you can protect the web services services generally. So let's we see here. This is what development. So you how you can able to do in the development using the JDeveloper or using the WLST or any one of the way you can able to go and design the application, and as well as design the policies and roles. Then after completing that, you can attach with the composite application, and you can deploy this composite application to that Oracle, service infrastructure. Either it may be a SOA composite. These whatever you have defined the policies for SOA composite service or ADF composites, you can use all the policies for same actually web center services, right? All the policies. Then these policies generally who are going to be administered generally security administration, and where you can able to administrate once you have prepared here in the EM console or WebLogic console, we can able to administrate by using the SOA administrator. Then in the administration console, what we will able to do only G2W application server or WebLogic web service, only those we can able to monitor and administrator. And policy management generally we will able to do that web services policy framework Oracle Web Services, manager policies and roles. By that generally which you can able to protecting the SOA composites. Right. What is a WebLogic? What is a Oracle Web Service Manager generally? So why what it is going to be doing? See, it is an generally what it is going to be doing. It is a security management generally. It is a security management which is used to enable security infrastructure for the web services application. Example, all the components. So in the EM console, generally what will happen? OWSM to centrally define the security and management policies. In the sense, from there you can define generally. It is going to be enabled to do the following operations generally: define, enforce, and monitor. And so how it works generally? Oracle Web Services, Manager Policy Framework (OPSS). In the sense, let's we see it has going to be enables the web services security consistently, and the policy framework generally is built in using the web services standard and Oracle Web Services Security Platform, you know, security services. So whenever you want to log in into the Oracle WebLogic server for authenticator or authentication and authorization, see here this for Oracle Web Server policy, and it has got to be providing the login modules, right? By using that login modules, and which you can able to protect the web services security policy. Example, what are the components generally which you have in the Oracle Web Services Security Manager? MTOM, security, addressing, management, reliable messaging, and from the Fusion middleware control you can able to manage or JDeveloper. And generally these details generally which is going to be stored under the metadata service in the Oracle Fusion middleware database. What it is each one generally? What it is each one? So that part we'll able to see. What it is each one generally. So this one. Great. Then what it is each one that generally those are the components generally which you can able to web services components which so in the EM console you can able to see how we can able to protect the web services by using these web services components. See, generally the web services policies, these are all called web services policy manager. It has going to be defines framework for allowing the web services to express their own requirements. See, generally, so by using this web services policy attachment and the policy assertions, generally what we need to do, we need to be protect the web services. It provides a model and syntax for describing the policies of the web services. So this is what policy assertion. In this way, generally they can define, and the service provider can use this policy assertion to convey a condition under which they offer a web service. So assertion one, assertion two, assertion n, then a number of assertion like request and response. So it is going to be conveying the information generally. The service provider use that policy section to convey a condition under which they are offer the web service. These are going to be executed in order which they are listed in the policy according to the requirement. So what are the supported policies generally which are going to be supported by using the Oracle Source 11G, WLS reliable messaging, management, and WLS addressing, security, message transmission optimization and mechanism for this actually. These are the four security policies which are going to be supported by the Oracle WebLogic server, sorry, Oracle server suite. Then we'll able to see while we are working with that, practical part. So how it is going to be policy interceptor, it is going to be monitoring. See, reliable messaging. This is actually for client when our clients make a request and over the network. And similarly like that, from web service, how you can able to invoke the service. From that also same process. These are the policy components generally which needs to be protected in the SOA composite applications. So one after other. So that is what generally which you can call it as. We'll see all the security policies. How to view the available web services policies generally. How to view the available web services policies. I'm just moving into that SOA console. Go to here, provide the username. Right. So expand the environment. See how to view the available web service policies which are available in the SOA console in the SOA suite generally. Expand the WLS domain. Right click on it. Go to the security and application policies. Click on it and select the SOA infra. Click on here. Services policies. See, these are all the default policies generally. These are all the default policies, right? policy authenticator, policy enforce messaging, policy, all these are the different default web services policies already there. Category, security, say I told you, right? Components, security, MTOM attachments, reliable messaging, WLS addressing, and management. Depends on the requirement you can able to choose actually, and you can able to search it. Okay. So for this actually, all these components which is used to for what purpose? Protecting. What is that? Service endpoints or service clients and so components. You have to be select anyone. Okay. By default service endpoints. To which one actually applying this one? So that you have to be know. So these are the default policies. You can able to see all these default policies applies to whom, and you can search based on this, right? So what are those generally which you can able to see now? See, here you can able to create, and as well as create the link, and all those we'll able to see later. This is how you can able to see that this is what policy web services assertion templates. In this way you can able to see that web services policy. What are the web services policies which are available in the SOA suite? So next, what I have to do, how to create the web services security policies, and what are the steps actually? The first one, steps is nothing but what just by using the already templates was there. By using those templates, creating the new policy from the existing policy, and importing the policies and implementing the custom sections also depends on the requirement. Let's we see how you can able to create the custom policies. So expand the, generally it would be like this, expand the SOA domain. Then after that, right clicking on the web logic domain, right clicking on the domain name in the EM console only. Go to the web services and click on the policies. Go to the web services and click on the policies. Next, what I have to do, so click on the create for creating the new policy. See what it has been. This is the policy name, and what we need to do here, check the identity and see policy name you have to be provided here. Okay, what is your policy name and why you are requiring, why you are creating the policy, that we need to be know here. This is policy name, and what you have to do, you have to select here for name, and then click on add. Then you can provide that the following settings, right? Go to over there and selected policies and click on add. See, this you have to be noticed for what purpose you are creating the service category, service binding or service components. So click on add. So you can select the policy. So whatever it is, and assertion name, click on OK. See, I added one policy, type logging, security logging. Then I can able to add some description here. Okay, what is my policy name? You have to be understand here. Okay, and you can click on the logging, and you can select which one you have to be protect while it is giving the request or whenever you are getting the response in the settings. Click on the add groups, and assertion name you can add and select the group also and click on OK. So already there I am giving the name actually, same thing, right? So then after that, what I have to do, and if you want you can delete this assertion name, depends on the requirement. So click on save button. Before that you can validate that. See, which is created. Go down at the end. See, path policy name, which I created one policy here. I can create one more policy again. Click on create. Right. Demo web service policy, otherwise demo web service. Okay. And click on add, not this one. need to be select SAML L2 message policy assertion, click on OK. So which I have created. I need to be provide the description here also for what purpose you have created that policy. Depends on the requirement. See, this is for while getting the request and while the service doing the response, and if you get any faults, how it is going to be getting that, how you are going to be using this security. Once I have done completely service creation, policy creation, click on save button. Go down. See where it is. Web services policy. See, demo web services policy which is available. So this way generally you can able to create the policies. Whenever you want to edit the policies, either it may be custom, whatever I created custom policies. Whenever I want to edit the existing policies, you can select the existing policy and click on edit, and you can edit the existing policies like this, for what reason you are created, and log messaging and G2W service authorization. So depends on that you can edit the policies and click on save button after you have done validate and click on save button. In this way you can able to validate the existing services. In other words, create and as well as modify the policies. I want to delete the policies which I created generally. Click on the delete policy and click on OK. So I can able to delete the policy, right? So in this way you can able to create, edit and delete and view the policies and import the import. Generally you can import from outside to inside actually the policies, and whenever you want you can export actually. So these policies you can export to the new or target environment. And for generating the client policies, you just click on here. You can generate the client policy. This is which you already want to be generating. My host port number example it is going to be showing. So for this, you have to be choose that right. How to generate the client policies means this is a way, or by clicking on the generate client policies, you can click on it. So this is how generally you can able to generate the client policies. In this way, you can able to create, modify, and attach and sorry, not attach, and create the client policies. So what are the restrictions of the security policies? Generally security policies can contain multiple security assertions. We have seen in that list, right? So it can be contain any number of security log template assertions. Just now I have created one. So by this generally what will happen, so you have to be create a number of it depends on the requirement, you need to create the security policies and you can edit. Just now I have seen. So how you are going to be securing that so on, as well as identity about that all the so composite applications. Assume like that whenever the request is coming from the web client generally which is processed through that BPL instantly, because BPL is the main component, right? So once it is received, it has going to be checks about that authentication and as well as authorization. If it is authorized user, generally it has going to be allowed to access it. Else, even though it is authorized user, generally it has going to be forwarding to that again at the component security level, which is forwarded to that SAML to authenticate and as well as verify the SAML token. All these generally which is going to be verifies. Once it is done verification, then only it is going to be allowed to access the end services. Until unless it won't actually. This is what actually web services policy token or WLSS and SAML token client policy. So while you are configuring that policy, you have to be configure this one and attach these policies to the composite application. So whenever it get request to that component, then it has been protecting. If it is authorized user, then only it has going to be allows to access that end solution or end service generally. In this way, you can able to secure, and policies can be attached during the in the JDeveloper, in the sense during the deployment development time in the composite.xml. So this will do by the developers generally. All the security policies attached in the binding of like composite.xml. Like this is example how it has going to be sourced. This is one way how you are going to be attaching the policies will do by the developer in the JDeveloper. So viewing and attaching the policies in the EM console, which will do by the administrator while he is deploying the applications generally, right? While he is deploying, so you can attach the policies, and during the deployment, you can attach detecting the policies by using the EM console, which will do by the WebLogic Server administrator. Sorry, SOA administrator. So log into this. What I'm doing, I'm just clicking on the SOA infra. right? Go to here, where it is. I'm just clicking on that any one of the application. Right. So click on the policies. Every component which has the one tab called policies. Click on policies. See, if you want, you can view the columns. Then after that, you can attach, and you can detach the policies. So what you can do: approve rule, approve human task, discount rule. To which actually you need to be attached the policies, right? I want to attach the discount policies. I'm just telling that one, right? So you can attach the policies generally like this fashion. You can attach, there is no it has going to be listing the policies here. Based on that, you can able to attach the policies to the, you know. So this SOA composites you can attach and detach from. When already you attach the policies means you can detach it. So this way you can detach the policies, in the EM console. So this is how you are going to be attaching and detaching the policies in the, EM console, and then after that you can monitor whether it is going to be giving the better performance or not from the SOA composite application. So this you can able to do in this, SOA composite level, how you are going to be protecting the SOA components. Then after that, how to create the user, then how to, how to create the application roles and application policies. Let's see generally how to create the user means, let us say we'll go to here, in the WebLogic console, click on the security realm and click on my realm, and how to create the group also. Click on users and groups. So click on new. I'm providing username and click on OK. And next what I have to do, click on username, and I need to be create the group. Then I have created user successfully. So next what I have to do, after completing this one, I'm just moving into this here actually. Uh, Click on the SOA domain, EM console, and go to the security. So here you may have the following actually. After completing the web services, security provider configuration, application roles and application policies and key stores and all those audit policy and sensitive policies. So we need to discuss about these application policies and application roles. So click on application roles. So these you have to be select so infra, and you can create the policies depends on the requirement. Application policies, these are all the application policies. So what you have to do, click on create, provide the policy name, and just selecting, and display name also same, then description, then add members. See, I'm selecting that group, and once I have done, click on OK. These are the application rules. Based on this also you can able to protecting, right? See, I have created this application role. Similarly like that, I want to create the application policies actually, right? Right click on here, go to the security and application policies. The moment you click on the application policies, it has going to display here so infra, and click on create, click on add first. See, create the grantee, and select that application roles, select it, and click on the permissions. For this also you have to be create permission or resource type. Generally, what kind of roles you are going to be creating here, and starts with See, so in this way you can able to create application roles and as well as the application policies. This is generally how we are going to be protecting the Server Composite applications. So this is how you're going to be creating the application roles and application policies. Even you can attach from here, go to the security. This and this both are same, whatever I have done. Go to the security, application policies. So you can create from here also same, and go to that security and application roles and application policies. Otherwise, right click on here, server domain, and go to the security. From here also you can able to do it same process, right? This is about generally how you're going to be, protecting the SOA components or SOA composites. In this way, we are going to be configuring the, security policies for protecting the services generally. Then after that, you can test the application with and without credentials supply with the client request. So this is about generally, we can call it as, security at SOA composite level. So then after that, let's we see the important one, so what is the metadata service? So later I will go with this high availability, very important one. At least you will get one or two questions. What is MDS generally? Metadata service. So why you are configuring that MDS generally? Okay. So it's very important metadata service. So what is generally metadata service and why you are going with MDS? It's a repository you can able to create while you are creating the RCU. So all the schemas you have created, right? Whenever you create the RCU, you can able to create that these metadata repositories. What are the MDS generally? MDS is nothing but what which contains Oracle Fusion Middleware components, all the runtime information which contains generally, right? Right, example the Oracle Server Suite and ADF, all the Fusion Middleware components data which contains under the Oracle metadata repository. It has going to be created while you are creating the RCU. So while you are installing. Then in metadata repository, it has going to be stores that all the, Oracle Fusion Middleware components are, at runtime. So generally, uh, a metadata repository generally it is a declarative metadata repository. It is a declarative metadata repository with Oracle Server Suite. It is used to store metadata of the components and web-based applications and that are developed to the service infrastructure, which is going to be stored at the runtime generally in the form of schemas. While component is being deployed, it's associated with the metadata only. So that information generally where it has going to be stored runtime composite information, including the component configuration, web services definitions, and business rules, dictionaries, and security policy definitions. All those generally which is going to be stored into that metadata service repository, made available to the service infrastructure at runtime. See, you have created and you have monitored and all those we have done for time being. Generally, whenever you stop and start the service, generally, where it has going to be stored and how it has going to be available at the runtime. So that it would be possible by using the metadata service repository. There are two types generally which are here we have generally metadata services. One, it could be a database based or file based. Database means the repository can be installed into the existing database using the repository creation utility, in other words, RCU. And with RCU, you can create schemas for Oracle Fusion Middleware components. You can create schemas during the installation of the RCU. Otherwise, after you create also, you can able to see that how you're going to be, creating that either it may be database based or file based, right? So MDS, in other words, generally you can call it as, metadata archives, generally compressed into the archive file, and you can deploy to the different target environments also, right? So, so generally by this, generally it is going to be providing that usability, reliability, and scalability for the database repository for all the production purposes. We use this MDS generally. How we can able to create you we already seen generally, so this is what generally like how it has going to be sourced the runtime information into that metadata repository, all the SOA composites application and whatever you're doing like that, business rules and the work managers. So all that information generally at the runtime it has going to be stored under the metadata repository. So what are the rules generally in this metadata repository which we are able to doing actually? See, registering a database based metadata service repository and managing and purging the metadata version repository and managing the dehydration store. All these generally which you can able to manage. These are the four responsibilities which you can able to do in the metadata service repository. So first one, how you can able to register the database based metadata repository. These are the steps actually. Log into the administration EM console generally. So click on the form, domain name and WebLogic domain metadata repositories and click on register database based and you do register the following way. So in this way, that's I'm going to over there. See, there are two ways. One is you just right click on here, go to the metadata repositories. This is one method. And second method, so second method, you have your metadata service repository, expand it. It is taking some time to expand. It's very, very important one actually. At least you'll get one or two questions from this topic, whatever I'm discussing now. So what is metadata repository and why we're using, then where it has going to store all the random information. So all that it is going to be asking actually. Right. So this is what generally expand the metadata repositories. MDS SOA. That is for first one is see, I'm just clicking on this MDS SOA. So it has going to be displaying here metadata service administration. So what do we need to do here? We can able to register and as well as delete and whatever you want you can able to get. These are the register. These are the registries or repositories which are going to be created while you are creating the RCU, and you can manage those labels and you can delete those schemas depends on the requirement. You can add and you can remove whatever you want. You can able to do it. Okay. Administration, you can register and as well as you can deregister. I'm just clicking on the register actually. See here. So the moment you click on the register, there are some, this is file-based register and as well as the database register. So for timing, you cannot able to do that file-based register because we have configured that database, right? You provide the name and directory and click on OK. So example, so I'm providing some name. So we don't have any name like that and directory. And so temp directory has multiple stores. Click on OK. So generally what it is a file-based repository. See, in the down it has going to be creates file-based repository, right? MDS SOA demo, which I created one file-based repository. So you can create most of the Fusion middleware component schemas repositories in a database using the repository creation utility. So what I have to do here, so successfully I have registered. It is not visible in the table after refreshing the page only. It has going to be visible. Then now you can able to configure the database based repository. So click on repository. See what I have to do. Database type is Oracle and host name localhost and port number 1521 and service name XC and you can query forgot. Okay. sysdb and click on query, which is already created, right? So you can query like this and you can create the database based repositories also. You just go to over there and click on query, then you can able to get like this metadata service repository, and otherwise you can create your own. So data custom repositories also you can create it. With this repository generally what will happen, WebLogic server domain, a system level global and non-transactional data sources named. So that is what the repository name, and it is also created along with it. So this way generally you can able to create it from the EM console. Otherwise by using the SQL statements also or SQL commands also you can able to create in the background. See here, this is another way of creating the or registering the metadata service. How you can able to managing the metadata, partitions, repository partitions generally. Create the new metadata partition and cloning, and as well as see what I have to do. What are the steps actually for creating the metadata partition? Log into the EM console, click on the WebLogic domain, and go to the system properties or system ambient browsers. That's we see. It otherwise, see you can go like this also. Otherwise, you just go to this SOA infrastructure and administration system ambient browsers. See, you can able to see not runtime MDS. Navigation I need to be check it actually. Yes. Application defined beans. So under this, right. MDS runtime and click on it. See here, create the partition or MDS domain runtime, then go to the operations tab, then create the metadata partition. Create the metadata partition. Click on it and you can provide the value and click on create or click on invoke the partition. So this is how you are going to be creating the metadata partition, right? So even you can able to create by using the SQL case statement, and how you can able to clone actually that same partition generally, one target environments to another generally, which may contains among other operations to clone a partition generally. So under the same path, application domains and domain runtime, and click on the operations tab and clone the metadata partition. You can clone actually from one. You can clone. See here, one metadata service to another metadata service. You can clone. So by using this also, you can able to clone the metadata repositories. Then go to the here. What I have to do? Click on the ambient runtime. I'm just clicking on it. So click on the return here. What I have to do? Clone the metadata service. You have to be provide all these details and click on invoke button, and you can able to click on invoke. You can able to invoke or something like that. Clone the partition. Then after that you can deploy those metadata services by using the WLST or any one of the method. So this is about how you're going to be managing with metadata services. Then what I have to do, how to export and import the metadata services generally. So go to the SOA infrastructure and administration and click on the metadata or MDS configurations. Generally, the moment you click on it, it's going to be displaying the following one. The first one, export. In the sense, you can export this existing, metadata services, whatever it contains in the repository, to the file system directory or archive, right? So I'm just clicking on the export. So export the metadata, from the where you can application running, you can export from this point to that part. And import means you can import the metadata documents from the file system directory to that inside. Actually, you can import outside to you know so infrastructure, you can import it. And purge means you can delete it. Actually, the version history of that, see, we can save this SOA infra metadata services. We can exporting to the .zip file. Generally, click on OK button. So then after that, you can import similarly like that. You can purge means some of the versions history generally. So it has going to be, applications registry partitions that are older than selected period. Generally, we are going to be, removing those, say example 0 to 1 day, 2 weeks, 10 weeks. I have to delete unwanted data actually, which I need to be purged. So by this, generally what I'm doing, I'm improving the performance. So this is about, these are the, operations which I can able to perform: import, export, and as well as purge the you know database repositories, metadata service repository. In this way, I can able to purge the metadata repositories. Then once I have completed, I'm just moving into the very important one called managing the dehydration store. So generally, what is the dehydration store and the transient store? Generally, dehydration store is nothing but what see, commonly generally, the metadata data service repository, which contains the small database footprint, in other words, simply which is used to store all the application metadata, common reusable artifacts, and runtime configuration changes. Another important schemas that will be require more frequent monitoring, right? Very close to the administration in the either it may be dev environment, production environment. It is used to store instance and transactional data of all the composites being executed in the infrastructure. So that will do by the metadata service, or dehydration store. Generally by default, it has going to be dehydration store only. And in the dehydration store, it maintains generally transient process means only small, short-term learning applications. Generally it has going to be sourced within the service infrastructure. But a dehydration store means whenever you want to run the, or whenever you want to maintain the long running applications, those information generally which is going to be stored under the dehydration store, in the sense of the database, their current status information while they are executing over the period of time. And storing the process in the database preserves the process and prevents, if you'll get any loss or state, generally it is going to be recovered from that, or you can able to recover from that, like any reliability issues, any shutdown, or network problems you'll get, so which are already stored in the network storage area, then we can able, sorry, dehydration store, we can able to recover from that dehydration store. By default, all the components in it, you can call it as dehydration store only, which is going to be stored under the database only. See, dehydration store generally how you can able to configure, then so by default I told you, right, that is dehydration store only, database based file only. I have showed you how you can able to configure that MDS repository, right? So it has going to be stored under that MDS repository only. Right. This is how you are going to be managing and maintaining with the dehydration store. Very important in the question, what is the dehydration store? So go to here, click on the refresh, administration and metadata service MDS repository. Then see all these generally which you have done. You can import, export, and as well as you can purge. And here go to here and metadata services and administration, attach, detach, and even see the one I created generally. So one MDS over demo I created, right? One file based repository. So which I have displayed here. See here. So click on this. Nothing was there here. Just now I created. Go to here and even go to this one. And what I have to do, right click on here. You can administrate, register, deregister, depends on the requirement. So this is how generally you can manage with metadata repositories. All the runtime information, what you are doing in the composite application, which is going to be stored under the dehydration store, in the sense in the database based. In those schemas, it is going to be stored. This is about how you're going to be registering, import, export, and purging the metadata repository, and what is the dehydration store, how you can able to manage it. So this is about that MDS service. Then after moving this, generally I'm moving into that very important topic called high availability. Another source, how you can able to configure the clustering in the SOA suite, configuring the availability for the SOA suite. See, we see. First, we'll able to see about that. What is a cluster generally first, and why you are configuring the cluster. See, cluster is nothing but what you know. So you are going to be connected by using the cluster. In other words, in the cluster can connect two or more interconnected systems. In other words, it is a collection of, or it is a group of two or more interconnected system, which is used to creating the solutions for high availability and as well as the load balancing and as well as scalability. All those generally which is enabled by using this cluster. Then cluster generally it has going to be provides in the source the following high availability solutions. Generally, how you can able to protect the components and applications from the problems, like whenever it has going to be down. And the downtime can be categorized like either it may be unplanned in the sense outage, this is or directly in the runtime automatic directly, or runtime without scheduled one automatically, due to some technical problems it has going to be get that some outage. Then planned means generally, see, we only plan for down the servers. That is what generally downtime we are categorized. So that is what one solution generally for providing the high availability. And second one generally we need to be reduced, which can be by using this the following mechanisms. The outage generally. So the first one, active solutions, and which is recommended generally. Active passive solutions, which is referred as a cold failover. The first one is hot failover generally. Second one is cold failover in the clusters. And generally, this availability more relies on the number of technologies and let's we see such as clustering. Then one is high availability is nothing but what even in the event of a failure, in the event of any one of the server or in the any one of the source server has going to be fails, no problem. So which is redirecting to that another server instance and continuing the processing. Further, generally, which we have the following technologies which is available under this. That is what cluster we are approaching, and how you can able to implementing the high availability solution in the server suite generally. There are two. I told you right. One is active destinations and sorry deployments. Second one active passive deployments. You just go to over there is what is active, what is active passive generally. Active means this is one machine and this is another server. This is server one and server two. Both servers needs to be present at the same time. Both it has going to be active at the same time. Active passive means one is active, another one is in standby state. Whenever this fails, so this comes into the active and continuing the processing. That is what cold clustering or cold failure. Then the other one is hot failure, right? Active deployments means all the instances handle the request concurrently. In the sense, all which are going to be active at the same time. How many servers do you have in the cluster? All the instances which is going to be activating or doing the or handling the request concurrently. Active passive means generally what it is. So the active instance handle the request and passive instance in the standby state. Whenever the active instance is going to be get problem, then passive instance it is going to be comes into the active and resuming the processing. So what are the technologies generally which you have here? Clustering, load balancing, failure, and process depth detection, automatic restart, and role patching. These are the different ways generally, so which you can able to provide for protecting the server composite applications. Sorry, not protecting, for providing the availability and as well as load balancing, right? So then after that, how the Oracle provides the availability solution generally. So this is what generally which you can call it as uh, high availability. Assume like that, this is what this is what one data center, this is what another data center, this should be available in San Francisco and this should be available in Colorado. So what happened by using this generally, see, this is one data center, this is another data center, it is going to be syncing, this is production data with another data center generally which is in a standby state. So whenever you will get any failure, this is single data center deployment generally. Whenever you will get any failure or when technically if it happen anything to this data center one, so that time generally what will happen generally, so this data center generally which is already there, right? Standby data center. The standby data center, what it is going to be doing, if it is unable to processing the request, it comes into it comes into the active and resuming the processing data and configuration. It is going to be syncing to this data center, and whenever it is going to be get any problem, this is called distributed deployment generally, like technically. So the standby data center which comes into the active and continuing the processing. This is generally one method. And second method, Oracle also provides the high availability architecture. In the sense, let's we see. This is cluster tile and web tile. We need to be configured to set up the load balancing and application tile. So you need to be create and add the SOA servers into the application SOA cluster and data center, and how you can able to handle the failures at the JDBC level also by configuring the you know Oracle rack or something like that. Multi-data source we need to be configured, and database level they are going to be configuring the rack. So this is about generally runtime information. One by one we'll able to see. We need to be configure this web tier and as well as cluster both in the admin console. So how to configure the high availability generally, and so this could be in two ways generally: clustering and service migration. So let's we see how we can able to configure that process. We'll able to see this practical part, how to configure in the WebLogic server domain. We'll able to see. Otherwise, during the installation of the WebLogic server or during the domain configuration also you can able to create. So then after that we'll see this how you can able to configuring the web server generally. How you can able to configuring the web server and integrating with the WebLogic server or something like that. SOA suite or SOA domain. That part we'll able to see. See, this is about how we are going to be configuring the multi-data source metadata service repositories generally for sharing the multi-data source in the shared storage, right? So by using this multi-data source generally, which we can able to configure at application level for protecting the data sources or for providing the high availability and score availability and load balancing to the data source level also, right? By using this multi-data source configuration. So we are giving, in the sense, we are sharing that metadata service in the sense service repositories commonly to other data sources generally, same metadata service. And then, so in the cluster generally, there are following features which are here we have generally active. The first one we need to be discuss about active deployments. This is web tier and this is application tier, this is data tier. Whenever the request comes to the web tier, generally what it has going to be doing, so it has going to be checks about the application servers which are available or not. So if it is available, it has going to be processing the request. See, in the active destinations, both servers generally which is going to be handling the request concurrently. In the sense, both are active at the same time, right? Even SOA server 1, it is going to be handling the request, and SOA server 2, it is going to be handling the request. It is going to store that runtime information in the metadata service repository. Clear? Active deployment means both are taking the request at the same time, or in other words, at the concurrently. So many servers which are available in the cluster, all nodes which are available, and so which are going to be taking the request concurrently, or which are processing the request concurrently. This is another word generally we can call it as hot failover. In the sense, running while running, it is going to be fail. What will happen? Request cannot serve generally from that server. Then active level to generally what it is without, this is without node manager generally. With node manager, whenever you configure, see, assume like that. So four servers you have in the cluster, four servers running, generally four servers which are running and which are processing the request. And assume like that any one of the server one is going to be fails, but you already configured the node manager. So node manager, what it will do, it is going to be, it detects the failures of the manager server instances or server instance, and it is going to be restart those failed server instances and continuing the processing. So in this way, node manager protects against the process failures actually. This is a level 2 active and active 2. The one is what this is the last one without node manager, this with node manager generally. So whenever the server one is going to be fails, here if server one fails, there is no way, only server two only handle all the requests. But here it is not like that. Node manager, it has going to detect the failures and it has going to be restart the failed server instances. And this is also coming to the running mode and handling the request only. So in this way, generally node manager protects, against the process failure, right? This is about the second, process or second way of implementing actually. And in the active generally with node manager and as well as the whole server migration. In the sense example, what is the whole server migration generally? Whole server migration is nothing but what? Whenever any one of the service or any one of the component which get crash, there is no problem, which are going to be recreated, same starting of the manager server, same manager server on the another physical machine. right? It is going to be recreate that, whole server migration intimated on the failure whenever it get intimated to the on failure. So that is what generally which you can call it as, server migration. If the server one is going to be fail, it is going to be recreates, that process on the different manager server instance in the in different, or in other words in another physical mission within the cluster. These three servers which are available in the mission 1, mission 2, mission 3, assume like that. So in the mission 1 is going to be failed, no problem, which is going to be recreate, which is going to be, recreates on the, you know server 2, which is running on the mission 2, in the sense in the different mission, and continuing the processing. This is what old server migration. See, in the whole server migration, generally what it has going to be doing, so it has going to be migrate or move all the services, different physical location or different physical server. So whenever you'll get any failure, see, this process will do by whom? Node manager generally. Node manager, what it requires? It requires perform the initial startup migratable processes, and you need to get all the servers of the migratable servers, and restart the migratable servers whose lease has expired on the mission where it is failed. So generally this is called, in other words, migratable servers. This feature generally which you have seen in the WebLogic server migration. And automatic whole server migration. This is manually WebLogic server administrator need to be performed. So it needs to be to the manual, automatic whole server migration. In the sense, node manager, it has going to be recreates. Here manual migration generally. If this fails, it needs to be recreated on the another physical machine within the cluster generally. But I want to do that auto migration generally. In that case, mission 1, mission 2, mission 3, and mission 4. The mission 3 is going to be failed, which are going to be recreated on the mission 4, right? By the node manager, in the cluster, right? It has going to be managed server to get configuration from the administration server and continuing the processing. This is what leads table. Then in this process, it is going to be, do that automatically whole server migration. So then after that, generally what I have to do, how to describe about the, Oracle configuration availability. Not only that in the Oracle source, all the components, how it is going to be using that Oracle, high availability. This is node 1 and node 2. So what we can able to do in this, so the applications that executes within the context of the Oracle WebLogic server, generally what it has going to bring, how it has going to be load balancing and failover within the Oracle SOA suite, or in other words, SOA infrastructure. That part we'll able to see. So cluster-wide deployment, how you can able to do that deployment? So that part we'll able to see. Cluster-wide deployment, then SOA infrastructure and all those. And active we have seen. Active passive means, first one we have seen active passive only, right? So next, high availability we have seen here. Then next, cluster wide SOA deployment. So whenever you deploy the SOA application into the service infrastructure, generally you're deploying to the cluster only, right? So when you're deploying, you're selecting the targets, like different targets. So those generally which are going to be deploying to that, so if you configure that coherent server, so it has going to be manages about the sessions generally, like all these, and load all the metadata repositories, and MDS repositories from the MDS repositories, and deploy it. Because all the applications, see, if you go to over there in the SOA application, which I deployed some application, how it is going to be deployed every time, where it is going to be stored under the metadata repositories. Whenever you start the SOA server, so automatically it is going to be loads all the deployment files, and it is going to be, deploying the SOA applications generally. That is what generally which we can able to do normally, right? So this is how generally SOA cluster wide deployment. Then SOA infrastructure failover. So this is what mission 1 and mission 2 and mission 3. So all the JMS subsystem data, transaction data, if you will get any failure, so all the request fail over, after restart fails, generally old server migration which comes into the picture, which is going to be, moved to the different physical machine, and which continuing the processing. Migrator services starts up and reads the change from the metadata repository. So example, the server is failed. It is going to be recreated on the server 2, and but it requires the all the runtime information, right, which has reached from the metadata repository. Like that, it is going to be continuous all the subsystem information, whenever it get failed. So at the BPL level, in the sense BPL process level, how you can able to consider the high availability generally. So BPL process engine, which is it is part of the SOA infrastructure, right? Then see here first what it is going to be doing: WebLogic server, SOA infrastructure, then later BPL engine, then so these all the dispatcher threads, in memory, process persistence, and audit level metrics. All these see BPL engine level GMS, dispatcher thread means HTMS messages, in memory means DDB messages, and persistent means SOA data sources, and audit metrics means under the metadata repositories. All this information generally which is going to be saved in the SOA database like this fashion. So in the active failover, in the active failover it will do like this. All this information generally which is going to be stored under this SOA databases. In this way you can able to perform the high availability in the BPL. So BPL process recovery, in the sense whenever it get failed generally, if waits the message is persisted at the time of failure, so while you are processing, it is going to be continuing after the failure, the process is triggered again by the activity waiting for the message. In the sense, it is going to be gets from the dehydration store and continuing the processing. Then now you can able to manage, mediator high availabilities generally. So this is also runs on the active stores in the database, applying faults and as well as automatic custom recovery. And so both for synchronous and as well as the asynchronous causes and errors, generally how you can able to handle asynchronous process means if the message is persisted prior to the failure, then processor continuing the post failure. And synchronous means it is expected to handle the error and retry. So in this way you can able to manage the mediator process recovery. Then high availability means generally in this recovery, generally whenever you'll get any pending transactions, any JMX messages stored in the local queue. So in that case, generally what we need to do, so by human workflow engine, it is going to be executing those JMS queues for the user notifications and all those. And UMS generally, so UMS most generally what it is going to be doing, it is going to be sending the notification to the specific channel, right? Which is more rely on the database repository, in the sense MDS or persistence for the persistent store. In other words, JMS distributed destinations for the load balancing, and JMS connection factory, JMS server in the event of failure. This is more rely on these generally these topics generally. UMS messaging generally based on this, which are going to be providing the failure and high availability. UMS does not participate in the any global transactions, which participates only in the local transaction. So how we are going to be managing the adapters? Similarly like this, JMS server needs to be configured migratable. So for that, adapters concept, either it may be FTP adapter, either it may be a database adapter or JMS adapter, doesn't matter. Then how you are going to be managing with Oracle BAM? In other words, high availability considerations generally. Oracle BAM considerations, how you can able to manage with the Oracle BAM, how you are going to be, active availability for the BAM reports. Server requires configuring and session replication using the WebLogic cluster. See like this. Sample BAM availability architecture this is, and how you're going to be managing application 1 and application 2. So in this way you can able to configure the BAM. See how you're going to be doing for the SOA suite. Similarly, you can able to do for the BAM also. So then after that, let's say moving into the practical part. How you can able to set up the failover and as well as the load balancing. There are following methods, right? So practical part. The first one, so configuration wizard for configuring the, and the second one, using the WLST also you can able to do, and third one using the admin console. So these three ways generally you can able to configure the clusters. So then after that, how to set up the load balancing. So for this generally we need to install the web server, either it may be Apache web server or OHS, and integrating with the SOA suite or SOA domain. So that part practically we'll able to see. Then after that, advanced cluster like coherence server, coherence cluster, and as well as server template and the dynamic cluster, that we'll able to see. Then after completing this, so we'll able to move to the performance tuning. So I'm stopping here. Tomorrow we'll see the practical part and we'll move to that performance tuning. Then finally we'll able to see that backup and recovery. Then last topic, how you are going to be upgrading from 11G to 12C. So these parts we'll able to see, okay? These topics we'll able to see tomorrow. Clear? Hello?
Okay, please.